Measurement and practical uses of electricity. Voltage is measured in volts with a voltmeter. Voltmeters are connected on either side of a circuit element like a resistor, battery, or light bulb. And here's our connecting wires here. You have a red and a black. So this is an electronic voltmeter. This is an old school analog voltmeter. Voltmeters are connected in parallel to measure the voltage across a circuit element. Since they're in parallel, the voltage measured in the voltmeter is the same as the voltage across the circuit element, in this case, a resistor. Current is measured in amperes using an ammeter. Amperes are often abbreviated as amps. Ammeters are placed in series with circuit elements. Here's your ammeter, like a light bulb shown here, or a resistor, to measure the current. The current through the ammeter is the same as through the measured circuit element as they're in series. Although there are separate instruments to measure current and voltage, there are devices that can measure both, one at a time, of course. These devices are called multimeters. They can also measure resistance in ohms. Fuses are electrical safety devices that protect electrical equipment from damage caused by excessive current. They also help prevent electrical shocks to people who come in contact with the wire with damaged insulation. They come in many different sizes and shapes depending on their application. So you can pause the video here and just take a look at the various different types of fuses. The simplest fuse has a metal strip that will melt when too much current flows through it. This breaks the circuit, so current will no longer flow. Since there is no more current, the electrical equipment will stop working, but it won't be damaged. In addition, if a person was in contact with the circuit, the person would not receive a shock as there is no current. After the fuse's metal strip is melted and the circuit is broken, the fuse must be replaced with a new one. Electricity was first used in homes in the late 1800s. It took a while for it to be universally deployed, and there are still many places in the world without electricity. Electricity is used for heating, lighting, computers, motors, and we'll show some examples on the next slide, and many other uses. The previous unit, magnetism, illustrated how an electrical current interacts with a magnetic field to rotate a metal core, creating a motor. The motor can then drive vacuum cleaners, electric vehicles, kitchen appliances, electric fans, record players, lawn mowers, water pumps, and many other applications that require a rotation. Light bulbs are lit with electricity, but most of the electrical energy is used to heat up the light bulb. Only 10% of the energy is transformed into light. The current passes through a thin tungsten filament in the light bulb. Tungsten has a very high resistivity. Since the filament is thin, it has a high resistance, so most of the energy is converted into heat, which is shown up here. Tungsten has a very high melting point, so it can withstand the high temperature due to the electrical energy. Electric train engines are powered by overhead electric wires. The power reaches the train motor via a catenary, that's this little shaped thing here, that is on top of the train and connects the bare electric wires to the wires in the train. As mentioned in the light bulb description, high resistive wires that draw large current emit large quantities of heat. Kitchen toasters and electric baseboard heating in homes use this concept. How much energy per time that an appliance uses is called power and is measured in watts. Earlier in the presentation, power was also defined as current times voltage. Household voltage is 220 volts in Eswatini. It's 110 volts in the USA. The voltage is maintained at a constant 220 volts no matter how many household appliances are connected to it. As more appliances are connected, the current is increased. Since the voltage remains constant, more power is consumed by the appliances. Larger appliances use more energy and have a larger power output than smaller ones, since P is equal to IV and V is constant. A washing machine uses more power than a light bulb. Light bulbs are rated according to their power. A 75-watt bulb uses more power and is brighter than a 40-watt light bulb. An average washing machine uses 400 to 1400 watts depending on its size. The Type M 3-pin plug is used in homes and businesses in Eswatini to provide electricity to lights, refrigerators, vacuum cleaners, coffee makers, and other household appliances. The casing was removed from this plug to show you the internal wiring. Click on wiring a 3-pin plug for a YouTube video on how to wire the plug. The blue wire, also known as the neutral wire, returns a current to the power company from the electrical appliance. The brown wire, known as the hot wire, carries current from the power company to the electrical appliance. And then the green, or can also be green and yellow, that wire earths or grounds the plug to prevent electric shocks. The hot wire is kept at a voltage of 220 volts. The neutral wire is kept very close to 0 volts. What if the hot wire's insulation is damaged and the wire contacts the surface of an appliance? Well, if a person then touches the appliance, the current could flow through the person and give a bad electrical shock. How can this circuit be made safer? The earth wire is also connected to the appliance. The earth wire is connected to the earth, hence its name, outside the building and has a very low resistance. People have a higher resistance than the earth wire, so the current will flow from the damaged wire to the earth, and the person will not be shocked.